Here we have a probability question that contains a little bit of algebra in it as well. So let's have a look at this then. The bag contains n plus 7 tennis balls. N of them are yellow and the other 7 are white. And John will take at random a ball from the bag. He will look at its colour and then put it back in the bag. Write down an expression in terms of n for the probability that John will take a white ball. So for this we need to know how many white balls there are, and we can see here that there are 7, and we also need the total, and we're told that it contains this many, n plus 7 balls. So for part 1, probability that John will take a white ball, well, that means that there are 7 white balls out of a total of n plus 7. So that is the probability in terms of n that John will take a white ball. For part 2, Bill states that the probability that John will take a white ball is 0.4. Prove that Bill's statement cannot be correct. Okay, so this uses the expression from part 1, and you're required to create an equation this time. So if the probability is 7 over n plus 7, then that equals 0.4. Because Bill is saying that the probability of picking a white ball is 0.4. So now we need to find this value of n. Now, if we're to prove that Bill's statement cannot be correct, then there must be something about that value of n that means that it won't be possible. Now, you can rearrange this and use your calculator, but I always prefer to use fractions wherever possible, and 0.4 as a fraction is 2/5. 4/10, which is equivalent to 2/5. So I'm going to dive straight in there and just rewrite this as 7 over n plus 7 equals 2/5. And now all I'm going to do is just to rearrange this equation. Now, the purpose of this video is not to detail all the rearranging, but how to answer this particular probability question. So if you're not sure about this rearranging, then you need to ask for some help on this. So to rearrange this, let's get rid of the denominators. And so on the left hand side here, I'm going to have 5 multiplied by 7, and multiplying the other side, got 2 multiplied by n plus 7. So we have 35, and let's expand the bracket, 2n plus 14, so that's the 2 multiplied by n and the 2 multiplied by 7. Now we need to isolate this n, so let's take 14 from both sides of the equal sign. So we end up with 35, take away 14, which is 21, and that equals 2n. And now we just want the 1n, and it's been multiplied by 2, so we divide both sides by 2, and so we end up with the n equals 10.5. Okay. Now, let's go back to the question. It says, Bill states the probability that John will take a white ball is 0.4. Prove that Bill's statement cannot be correct. Well, for that to be correct, 0.4, then there must be 10.5 yellow balls. And we need an integer value, a whole number of balls. So therefore, because that value of n is not a whole number, then Bill's statement cannot be correct.